OK, so how do you actually execute this Kaminsky attack that we talked about? We know that the high-level idea is to use fake domains, because that way nothing gets stored in the cache. And an attacker that loses can try again immediately, because there's nothing useful in the cache. So one precondition to make this attack work is Mallory needs to trick the resolver into making all of these fake requests. Usually, you're not going to be typing all of these fake URLs into your browser one after the other to give the attacker lots of tries. So somehow the attacker needs to trick you into making all of these fake requests. One possible way to do it, but not the only way, is to make a website that has all of these image tags in HTML. So if your browser goes to Mallory's website, then your browser is going to see this image tag and think, I need to go to fake1.google.com to load an image. So you're going to make a DNS request to find this domain, and it's not going to exist, and this will probably just return an error. But at that point, it's too late. You've already made this DNS request. Then your browser sees this image tag and thinks the same thing. I have to go here to fetch an image, so I'll make a DNS request to find this domain. I guess it doesn't exist. I'll show an error to the user. But as the browser processes all of these tags, your browser is making tons of DNS requests. And by doing so, you're giving Mallory tons of chances in quick succession to race against the real name server and try to poison your cache. So this is just one possible way for Mallory to trick Alice into making all these requests. Other ways are possible, but usually, because Alice is not going to go and type all of these herself, Mallory has to trick Alice into making all of these requests. So that's the first step of the Kaminsky attack. Trick Alice into making all of these fake requests, because that lets Mallory try many times in quick succession, as opposed to once every week. So now let's see what happens in a bunch of pictures. So here is Alice's cache. We'll say it's blank. Here are a bunch of name servers that she might contact. And Alice's queries are in orange, and Mallory's queries are in red. That's the setup. So Alice asks for fake1.google.com's IP address. Why would Alice ask for this? Probably not because she typed it into her browser, but because Mallory tricked her, using that image tag trick or something else, into making this request. So Alice has been tricked. She makes this request and wants to know this IP address. So she goes and asks, and she says, what's this IP address? And my request has this particular ID number. So when I get a response, it needs to have the same ID number. And if there was no attacker, then the root would say, I don't know, go talk to this next response, or this next name server. And the response has the same ID number, ID 161. And then she makes another request. It has another ID number that's randomly generated. And a response comes back, and it has this randomly generated IP number, or ID number. And remember, all of this time, we're dealing with an off-path attacker. So the off-path attacker doesn't know these numbers. If they were on-path or man-in-the-middle, they could just read these numbers and inject the answer right away. The Kaminsky attack is mainly focused on those off-path attackers who don't know this number. And anyway, eventually, Alice goes to the google.com name server, asks for this fake domain, attaches another random ID number, and this time, the google.com name server will say, this thing doesn't exist. You have asked for a non-existent domain, and here's the matching ID number because that matches with your request. This is what is supposed to arrive, and Mallory can instead try and say something fake. So there's lots of different fake records she could say. One possible fake record might say, there is a fake1.google.com name server, and it has the name www.google.com. Now, is that true? That's not true. There is no fake1.google.com zone. But maybe you pretend that there is one, and it has name Google www.google.com, and it has this malicious IP address. So what goes in this red box is kind of up to you, but you just need something that contains this malicious A record with the IP address of www.google.com. That's one possible malicious record. Other ones exist. So here's the race condition in a picture. This is the legitimate answer that says, the thing you asked for doesn't exist. This is the malicious answer that includes that malicious record, and Mallory has to guess that ID number correctly and win the race for this red malicious record to be accepted into the cache. So if she wins, that's great. Then her malicious record shows up in the cache, and it stays there for a week. And now Alice will visit www.google.com by talking to Mallory. She's made herself a man in the middle. And at this point, the cache is poisoned, so Mallory has won. That's what it would look like if Mallory won the race and guessed the ID number correctly. So what if Mallory guessed it wrong? Remember, she's an off-path attacker. She doesn't know that the request was 774. Maybe she guesses a totally wrong number, or maybe she loses the race condition. If she loses, then this answer will just get rejected because the ID doesn't match. The legitimate answer shows up instead, but this is the key idea that makes the Kaminsky attack so powerful. Unlike our previous attacks, where Mallory losing means that the real www.google.com is now stuck here for a week, because Alice requested a fake domain, if Mallory loses, then the only thing that gets cached is that fake domain, and it says it doesn't exist. This is not a useful thing that Mallory cares about, so she still has a chance to poison www.google.com. That's why the Kaminsky attack is so powerful. It doesn't cache anything useful when Mallory loses. So how does Mallory make the attack succeed? Well, then she has to start guessing ID numbers. So instead of just sending a single response back and hoping that she wins on her first try, if she loses, instead of waiting for a whole week, she can just try again. There's going to be a request to fake2.google.com, and she can reply with a malicious packet for fake2.google.com. If she wins that one, it has a malicious www.google.com record. If she loses, that's fine. She'll try again when the request to fake3.google.com happens. So many requests come in, and Mallory spoofs on every single attempt. So she tries over and over and over again. Every time Alice makes a request to one of those fake domains, Mallory sends a fake response with that same malicious record, and she guesses a different ID number over and over and over again. And with enough tries, she might luckily guess that right ID number, and then her response would get accepted, and the cache would get poisoned. So Mallory would have to try a lot of times, but the key idea, to say it one more time, is trying once every week, or as many times as she wants to. That's the key distinction that makes this attack possible. So now, if Mallory has succeeded, then when she tries to figure out the IP address of www.google.com, then the recursive resolver looks in the cache and says the answer is 6.6.6.6, and any traffic that Alice sends to www.google.com, like her Google password or sensitive search information or trying to send an email, all of that data goes to Mallory first, and she can play man in the middle to try and modify or drop any of that data. So to summarize the Kaminsky attack, it's something that does take a little bit of staring at to wrap your head around. It's a bit of a tricky topic, but this grid, I think, summarizes some of it. If the attacker correctly guesses the ID number and beats the race condition, then their record gets cached. But if they guess the ID number wrong, or they lose the race condition, then they fail and they have to try again. And if we're not using the Kaminsky attack, they have to wait a week to try again, because the real www.google.com record gets cached, and the cache is not going to be erased for a week. So the resolver is not going to make any more requests for the whole week. But with the Kaminsky attack, they can try again immediately. So they still lose, but nothing useful gets cached. They can try again immediately. So one final thing about the Kaminsky attack that sometimes people ask, is why bailiwick checking doesn't stop this attack. If you focus on these two responses, they're both coming from the google.com name server because we asked for fake1.google.com. Now, because this is the google.com name server, www.google.com is in the zone for google.com. So in other words, bailiwick checking doesn't stop this because google.com is allowed to serve www.google.com. That's something that people sometimes ask. So that's the whole story behind the Kaminsky attack. And these are the two scenarios before and after.